Welcome to 11.3 Arithmetic and Geometric Means, as well as 11.4 Introductory to Series. The warm-up says find Km if Jm is 4 and ML is 25. I would pause the video and see if you can remember how to do this from geometry. But anyway, we have a right triangle and we have an altitude drawn to the hypotenuse. So in geometry there was altitude on hypotenuse theorems, which basically said the length of the altitude is the geometric mean between the different segments that it basically ends up intersecting of the hypotenuse. So we know that x is the geometric mean between 4 and 25. When we solve this, we cross multiply, we get x squared equals 100. Algebraically, we would say x equals plus or minus 10. However, x can only be 10 because we're using a geometrical figure. Now, what are geometrical means? Geometrical means are special averages between numbers, and basically what you're doing is you're taking a number, 4, and you're trying to get to another number, 25. Well, what you're finding in between is the number such that when you multiply 4 by some number, we'll call it r, you get the number in between 4 and 25, and when you take that number that's in between 4 and 25, you multiply by the same r and you'll get 25. That's basically a geometric mean. So in this case, 4 times r squared would equals 25. So if you solve this, you'd get r squared equals 25 fourths, and r would equal plus or minus 5 halves. And if you multiply 4 by 5 halves, you get 10. And if you take 10 times 5 halves, you get 25. So if we use that logic for geometric means, in example 1, it says find 3 geometric means between 6 and 96. So we have 6, and we want to find 3 numbers such that when we multiply by a common ratio, which you'll recognize from the previous lessons, it is geometric. If we multiply by a common ratio r, we should get 3 different numbers in between 6 and 96 that are all the same multiples apart from each other. So we're going to multiply by r, and what you'll notice, you have to multiply by basically r to the fourth. So 6 r to the fourth equals 96. If I solve this, I get r to the fourth equals 16. And if you were to solve the fourth root of 16, you would think it would be plus or minus 2, because positive and negative 2 could work here. However, one thing to take note is that at this step right here, we could make that r squared equals 4. Or we could say r squared equals negative 4. And the reason I broke it down into this, because I don't know if you see it from r to the fourth equals 16. But if you think back to first semester, r squared equaling 4, then r could equal plus or minus 2. That's what we got for our original answer. However, if r squared could equal negative 4, then we now know that r could equal plus or minus 2i, because we have imaginary numbers in the game. So when we think about what are all the answers here, if we started off with 6 and we multiplied by 2, we would get 12, we would get 24, we would get 48, and then the 96. However, if we started off with 6 and we multiplied by negative 2, we would get negative 12. Multiplying by negative 2, we'd still get 24. Multiplying by negative 2, we'd get negative 48, and then we would get 96. But if we use the imaginary cases, we could start off with 6, and we could multiply by 2i, so that would be 12i. We could multiply by another 2i, that would give us negative 24. We could multiply by another 2i, that would give us negative 48i. And another 2i would give us 96, because remember, I squared is equal to negative 1. So I'm using that fact to get those numbers. And then we have to do one more last one, and we would have to say, if we had 6 and we multiplied by negative 2i, we would get negative 12i, negative 24, positive 48i, and 96. So there's actually 4 different answers to this question of 3 geometric means. Since we're doing it, it doesn't say over the reals or anything like that. Arithmetic mean. Hopefully you remember arithmetic mean. It's a fancy word for average, basically. The average of a set of numerical values calculated by adding them together and dividing by the number of terms in a set. That's something that you've grown up learning. So if we move on to example 2, we want to figure out 4 arithmetic means between 37 and 51. So if we use the same visual, 37, we want 4 arithmetic means between 37 and 51. Well, think about if we're adding up the numbers and they're going to be a certain distance apart. So that distance is a common difference. So we have to add the same exact number to each number to get the next number. So when we look at this math, we're saying 37 plus 5d's must equal 51. Well, if we solve this, we get 5d equals 14, and d would equal 2.8. Well, 2.8 is basically our slope, and if we think about arithmetic sequences from the previous lessons, that we know that we're going up by 2.8 each time. So the answer here would be, the 4 would be, so we'd start off with 37, and then we would go 39.8, 42.6, 45.4, 48.2, and then if we add, we get 51. So now we're on to 11.4. What is a series? The indicated sum of the terms of a sequence. The nth partial sum of a series is the sum of the first n terms of that series. So basically a series is adding up all the numbers in the sequence, and then when you're doing nth partial sum, it's telling you only to add up a certain amount of those numbers. So like the first 2, the first 3, etc. So let's look at the example. Given 3 plus 5 plus 7 plus 9 plus 11 plus dot dot dot. The dot 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 is ellipses marks, which means it keeps going on. We don't know how long it goes on. It's going on forever. So they want you to find the second partial sum, the third partial sum, the fourth partial sum, and the nth partial sum. So the second partial sum would be denoted s sub 2. And all that's saying is do 3 plus 5, which we know is 8. The third partial sum would be simply taking 3 plus 5 plus 7, or essentially you can take the 8 from this second partial sum and add 7 to it, and we'll get 15. And then the fourth partial sum would be adding 3 plus 5 plus 7 plus 9, which gives you 24. But what about the nth partial sum? The nth partial sum is a little trickier because you have to add up n amount of terms. Well, there's no fundamental way to represent that, because how many terms do you want? You want n amount. So what you have to do is you have to use what's called sigma notation. Sigma notation is a Greek symbol. It kind of looks like a fancy E, but it basically means add up or sum a certain number of numbers in the sequence. So to do this representation for the nth partial sum, what we have to do is we're going to start off and say n is going to equal 1, the first number in the sequence. So that represents the position. So we want the first number in the position, and we want it all the way up to n numbers. And then what we're going to do is we're going to say, what is the formula that's going on here? Well, if you look back from previous lessons, good review, see if you can pause this video and find the actual pattern for the sequence, or the formula. And what we look at is, remember, we have t sub n, or a sub n, would equal, and we can do this a lot of ways, but I like, if you remember from my previous lessons, I like to just basically say, what's the slope? The slope is 2, so 2n. And what would be the y-intercept? That would be the number that would come before 3. So if we go 2 back, we have plus 1. So this is the pattern in our sequence. Well, what that does is that allows us to put the 2 in plus 1 here. So I want to make sure you understand this. This is the starting position, the starting spot. This will be the ending spot. This will be the pattern or equation of your sequence. So let's use an example of this. Look at example 4. It says find the summation of 1 to 60 for the sequence 2n plus 1. So I'm using the same sequence we just found, but what we can't actually find the previous one because n was the top number. But now they're saying, you know what? We want the first 60 numbers in this pattern. Now imagine if you went back up and did it by hand, where you expanded it all out and added the first 60 numbers. That'd be very time consuming. So I'm going to show you a way on your calculator to quickly do that. So I'm going to change over to your calculator. So on your calculator, you'll have to open up a calculator page, and right next to the book, if you touch this button right there, we've used this all year long, you'll notice that there's a sigma notation button, and we're going to select it. And when that pops up, right here we can put in our variable. Now you can put in any variable you want, but we're going to use n. And right here we had 1, and the top number was 60. Now what's very important is that when you put your formula in, use the same variable that you had at the bottom of sigma. Because if you don't, this won't work out. But now it's going to tell the calculator, go ahead and add up the first 60 terms. So then all you do is you press enter. 3,720. So this answer is 3,720. All right, we got one more left for you. Expand. This expansion basically doesn't want you to find the actual sum, so it doesn't want you to type it in the calculator. But when you look at it, you'll notice that, is it geometric? Is it arithmetic? Is it neither? Well, we know it's not arithmetic because we're not adding, it doesn't look like a linear equation. And it's not, it's actually not geometric because the k value is in the power, and we also have k kind of staying out to the side, so it doesn't necessarily look like our geometric form. So let's see what happens in this one. So what it wants us to do is we're going to plug in 1. And we're going to add, if we plug in 2, and we're going to add as if we plug in 3, because k is going to be the position. And then we're going to add in the fourth one. And that's the expansion of it. But I want to simplify this a little bit and show you what happens when we write this out. So we're going to get -1 plus 2 minus 3 plus 4. What's interesting about this one, and in math you'll have to start to recognize this, this k in the power is basically making what we call an alternating series. The signs are changing as you go because the power, whether it's odd or even, is dictating whether it's positive or negative. So this would be your final answer, -1 plus 2 minus 3 plus 4, because the directions say expand. If the word expand was not there, then you would actually add up all the terms and figure out the final sum like we did in example 4. Good luck, ladies and gentlemen.